Simplifying further, negative 21 minus 10 gives us negative 31 plus 29i all over 53. Now you need to check with your teacher here, because some teachers are okay with your writing your answer in this form, while others say complex numbers need to be written in a plus bi form, and they will ask you to rewrite this specifically in a plus bi form, which gives you the 29/53 as the value of b in front of I. Technically, this second way is more correct when it comes to writing out your solution. For this next problem, let's multiply by the complex conjugate 4 plus 2i over itself 4 plus 2i. Up in the numerator, we're going to have a FOIL problem. We're going to have negative 24 minus 12i plus 12i plus 6i squared. And down in the denominator, we're going to have 16 for the first term. The middle terms will cancel, and we'll have minus 4i squared. Now, I notice in the numerator, my 12i's will cancel each other out. This 6i squared is a 6 times negative 1, so that's really a minus 6. And this minus 4i squared is a negative 4 times a negative 1, so it's really a plus 4. So up in the numerator we have negative 24 minus 6, which is negative 30, and the denominator becomes 20, and so that will reduce to negative 3/2. Previously, we have not been able to factor the sum of two squares because it would never work. But now we can factor them. We're going to treat it just like the difference of two squares, x times x. If this were the difference of two squares, we'd have plus 5 and minus 5. But this is going to become plus 5i and minus 5i. Notice we're multiplying conjugates, so the middle terms will cancel, and the L term of FOIL, when you multiply these together, gives you negative 25i squared, and you know that's going to be positive 25. So you can factor the sum of two squares just like the difference of two squares if you stick an I at the end of each parentheses. Most of us are uncomfortable factoring this using real numbers or even with that root 18 there, but we can do what we just did a moment ago. X plus the square root of 18, x minus the square root of 18, and stick an I at the end. And the square root of 18 is actually 3 root 2. So x plus 3 root 2i and x minus 3 root 2i. Now let's look at the powers of I. Whenever we see I, we're going to leave it as I. Anytime we see I squared, we're going to turn it into negative 1. I to the third, however, is going to turn into negative I. Now let's take a look why. I to the third is I squared times I. I squared is negative 1, so negative 1 times I is going to give us negative I. I to the fourth can be thought of as I squared times I squared, which is negative 1 times negative 1, which is equal to positive 1. Once you go beyond I to the fourth, you don't break this up into terms having I squared inside, you have I to the fourth inside. Let's take a look at I to the fifth, I to the sixth, I to the seventh, and I to the eighth. Each of these can be thought to have an I to the fourth inside of it. And the I to the fifth will be I to the fourth times I, next one times I squared, next one times I to the third, next one times I to the fourth. Well, if you think about it, each of these I to the fourths basically are 1. And so the answers that we get will be the same as what we had over here at the left. I to the fifth will equal I. The next one will be I squared, which is negative 1. Next one, I cubed, which is negative I. I to the fourth, which is then positive 1. So every 4 powers are going to keep rotating through these numbers that we have here. Now there's a shortcut way of handling this. Instead of writing I to the 51st is I to the fourth times I to the fourth times I to the fourth, etc. What we're going to do is we're going to say 51 divided by 4 is 13. Let's make that 12, remainder 3. What is this 12? Well, that says I've got 12 groupings of 4, and so I can take that remainder of 3 and say I'm going to have I to the third instead, which becomes negative I. Let's try that again. For this I to the 101st power, go 101 divided by 4 is 25 remainder 1. Only pay attention to that 1 remainder. This is I to the first, or equivalent to that, which means this can simplify to I. One more time. I to the 80th. 80 divided by 4 is equal to 20 remainder 0. Now you can treat this two different ways. You can say, well, this is just a 20 of the I to the 4th, which is 1 to the 20th power, which is 1. Or you can think of this as just taking that remainder of 0, I to the 0. Anything to the 0 power is equal to 1.